Good day. Our lesson for today will be equilibrium of four systems. When we say that a body is in equilibrium, the resultant of the forces acting on that certain body should be equals to zero. That is, your summation of forces along x will be equals to zero. Your summation of forces along y will be equals to zero. And then your summation of a moment at any point should be equals to zero. Okay. Now the physical meaning of equilibrium as applied to a body is that the body either is at rest or is moving in a straight line with a constant velocity. Okay. Now to properly deal with forces, you need to draw the free body diagram. And what is this free body diagram? Is an isolated view of a body which shows the external forces exerted on that particular body. So you have to show the external forces acting on that body. That is your free body diagram. Okay, these external forces are caused either by direct bodily contact or by gravitational or magnetic attraction. Okay, now we have several points to remember in equilibrium forces. Two forces are in equilibrium if they are equal and oppositely directed. So meaning uh, the magnitude is the same but the direction is opposite. Okay, equal ang magnitude and opposite in direction. Three coplanar forces in equilibrium are concurrent. So the same, when we say concurrent, that is uh, your forces acts on or acts at the same point. Okay, then three or more concurrent forces in equilibrium form a closed polygon when connected in head to toe head to tail manner. So let's say for example that you have this force F1, that is your uh, this is your head, this is the tail. Okay, and then you connect this one, and this is your F2. Then you have another force F3. So if those forces of this, or if these forces are in equilibrium, they should create a closed polygon. So that is for three concurrent force systems. Now if you have four concurrent force systems or more, let's say for example that this is your force 3, this is your force 4. So yeah, you should be able to create a closed polygon if those forces or concurrent forces are is in equilibrium. Now we have several steps in drawing a free body diagram. So first is draw a diagram of the body completely isolated from all other objects. Then represent the action of each body or support that is removed by a force or its components. Label its force by its magnitude if known or by symbol if unknown. So we have these typical types of body. We have the earth, quartz, small surface, ruler, pin, or hinge. Now this is the diagram. Okay, then if you remove the body, I mean if you will draw the free body diagram for earth, this will be the free body diagram. Okay, so and for cord, flexible cord, always remember that for cord, rope, or cable, your those types of members will only carry tensile load. Okay. Tensile load will act or will tend to elongate that particular body, so this will be your free body diagram for uh, the rope or the cord or the cable. Okay, and then this is your smooth surface. Okay, for any type of surface, body connected, I mean in contact with a smooth surface, your reaction is always perpendicular to the surface of contact. Okay, so this is the surface of contact, this one, point. So the angle in between, this angle, this should be 90 degrees. From the incline, or from this incline, you turn 90 degrees, that is the angle, or I mean that is the normal reaction at that point of contact. Okay, now we have this roller support. Now for roller support, uh, your reaction is only one. So ang imong reaction is only one, that is always perpendicular to the surface of contact. So kung horizontal ang imong surface of contact, meaning your reaction should be vertical. If that is inclined, let's say for example, this is your inclined surface of contact, then your reaction should be perpendicular to that incline. Okay, so that is your reaction. Now for smooth pin or hinge, bisan pa kung sa ang orientation sa imong smooth pin or hinge, you have your Fx and Fy. Okay, that is the Fx is the horizontal component of the reaction at that hinge or pin, and then Fy is the vertical component of the reaction at the pin or the hinge. Okay, now let us discuss the equilibrium of concurrent force systems. When we say concurrent force systems, that force they have a common point of application. Okay, so the sum of all forces in the x direction or horizontal is 0. So, and the sum of all forces in the y direction or horizontal, or this vertical, sorry, this is vertical, is 0. So Fx or horizontal Fh is 0, Fy is equals to 0. So these are the conditions of equilibrium that you will be able to apply if you have concurrent force systems. Okay, or when dealing with equilibrium of concurrent force systems. So duha ra ka conditions of equilibrium yung pwede ma-apply. Summation of forces along x is equals to 0, and then summation of forces along y is also equals to 0. It is important to note that with two conditions of equilibrium, only two unknown quantities can be determined to create equilibrium of concurrent force systems. So if you have more than two unknowns for a concurrent force system, your system cannot be solved because you can only use two conditions of equilibrium. We recall sa ato ang algebra, uh, for you to be able to solve equations or unknowns, you should come up with the same number of equations. Let's say, for example, you have three unknowns, so you need to have three equations to solve for the values of those unknowns. Okay? Okay. Now let us try to solve this problem. So the cable and boom shown in the figure support a load of 100 pounds. I mean 600 pounds. They determine the tensile force T in the cable and the compressive force for C in the cable. Okay, so force T and we have force C. Simply. Okay, now looking at the figure 3 P308, your 600 pound force is applied at point A. Um, this is your boom, and this is your uh, cable. So again, recall that for cables, it is only capable of carrying tensile load, okay, or tensile force. So this one, kining imuhang boom, pwede na sa compression, pwede sa tension, but based on the diagram, the boom will undergo compression, or it will carry compressive force, while your cord or cable will carry tensile force. Now uh, do that, or to further simplify the problem, you need to draw the free body diagram. So again, you have your 600 pounds force that is downward, your compression force, and then your tensile force for cable. Okay, if you will look at the diagram, okay, look at the diagram, kung mingon ganitang compressive force that is towards the joint. Where is your joint? This is joint A. Towards the joint. Kung ingon gani po tag tension or tensile force, that is always acting away from the joint. So this one. Iya gibitad, that is tension, gibitad, and then compression, iya hangi compress. Okay. So we have the first method using horizontal and vertical axis. So normal nga axis atong gamiton. You have this as your horizontal axis, your y-axis. Then you have this as your vertical axis or your y-axis. So that will be our normal axis. So summation of forces along horizontal is equals to 0, assuming all forces towards right or towards the positive x-axis is positive. So this is your horizontal component of the compression force. So we have C cosine of 45. See? C cosine of 45. That is positive because that is acting to the right. And then the horizontal component of your uh, tension or tensile force is acting to the left. So that is minus t cosine of 30 is equals to 0. So that will be your first equation. Again, you have two unknowns, the values of c and t respectively. So you need to create another equation for you to be able to solve the two unknowns. Okay, so you need two equations. We already have the equation 1, so we try to solve for the equation 2. Apply summation of forces vertical is equals to 0, assuming forces upward will be positive. Okay, so the vertical component of the C or compression is upward. Okay, upward, so that is positive, that is C sine of 45 plus ang imuhang vertical component sa imuhang tension is acting upward. So, plus gyapon, plus t sine 30, while ang 600 is downward, so that is minus 600 is equals to 0. So, using equations 1 and 2, solve for the unknown values. Okay, so dili na ta mag-discuss kung unsaon na pag-solve. You do that using the knowledge that you have uh, earned from your previous subjects, especially algebra. Two equations, two unknowns. So your tension should be equals to 439.24 pounds, while your compression is 537.94 pounds.